Diffusion is the net movement of molecules down a concentration gradient. This process allows small molecules, such as oxygen and carbon dioxide, to cross the plasma membrane. Most polar molecules, such as sugars and proteins, cannot freely cross this lipid membrane. Although water molecules are polar, they are small enough to pass through the membrane freely. This special case of diffusion that involves the movement of water molecules across a membrane is called osmosis. If a molecule, such as urea, is added to one side of a membrane, it will not be able to diffuse across the membrane because it is both large and polar. Because of its polar nature, it will interact with other polar molecules such as the water. This interaction reduces the number of free water molecules on the right-hand side. With fewer free water molecules on the right-hand side, there is now a net movement of water molecules down their concentration gradient to the side with the urea molecules. Because more water molecules are moving into this area than are leaving, the water level on the right side will rise. If the osmotic concentrations of two solutions are equal, the solutions are isotonic. However, when the solutions have unequal osmotic concentrations, the solution with the higher concentration of solutes is hypertonic, and the solution with the lower concentration of solutes is hypotonic.
Hi students, so we discussed with the same chapter today, that is solution and colligative property. In the last lecture we have discussed with the third colligative property, that was depression in freezing point. Now in today's lecture we will discuss the last colligative property, that is osmotic pressure. Now before going to the osmotic pressure, first we should know what is meant by osmosis, and in order to study the osmosis we should know what is meant by diffusion. Okay, now what is meant by diffusion? See here, first we will see the definition here. The movement of any substance, the movement of any substance from the region of their higher concentration to lower concentration. Once again, the movement of any substance, the substance may be solid, liquid or gas, from the region of their higher concentration to the lower concentration is called as diffusion. So in order to know what is meant by diffusion, suppose I have taken here two compartments, one having a solution 1 and second having a solution 2, and these two solutions is separated by a membrane. I have taken here simple membrane. So here I have taken a simple membrane which having a big holes. Okay. Now solution 1, suppose having a C1 concentration and solution 2 having a C2 concentration. Suppose we say C1 is greater than C2, means the concentration of solution C1 is greater than concentration of solution, that is C2. Now concentration is greater. Please remember, जो भी solution का जो concentration होता है, और concentration of the solution depends on the number of solid particles. More amount of solid particle means more is the concentration. So here solution C1 having a excess of solute, yes, because concentration is greater and concentration depend on the number of solid particle, and solution C2 having less number of solid. Less number of solid means it has excess of solvent. Once again, solution of C1 having a excess of solid, and solution C2 having a excess of solvent. Means excess of solid means high concentration of solid. C2 having a excess of solvent means having a higher concentration of solvent. So as for the definition, what is diffusion? The movement of any substance from their higher concentration. So here from concentration C1 to C2 or solution 1 to 2, what will be flow? There will be a flow of solute from C1 to C2 because concentration of solid is excess in C1. So there is a flow of solid molecule from C1 to C2. Same here. If we talk about the solvent is excess here. Means the concentration is more, to higher concentration to the lower concentration. So solvent will move from C2 to C1. Solvent will move from C2 to C1 because concentration of solvent is high here and concentration of solvent is less. Now, but the movement of solute will be taken in both sides. Solute molecule will be flow from here to here, here to here, as well as solvent molecule will move from here to here. But the resultant or net flow is depend on the higher concentration. So we can say the net flow, we can say net or resultant movement of any substance from the region of higher concentration to the lower concentration. लेकिन यहाँ पे क्या होगा? If C2 are taken, so concentration of solvent is more, so flow will from C2 to C1. In this C1, the concentration of solid is more, then solid will be moved from C1 to C2. So this is the concept of diffusion. Now we will see here what is meant by osmosis. Okay. Because all are connected, diffusion, we should know diffusion is connected with osmosis. Osmosis is connected with the osmotic ratio. Okay. Now osmosis. So once again, I taken a 2 compartment. Okay. One having a once again solution 1 and second having a solution 2. Solution 1 having a C1 concentration and solution 2 having a C2 concentration. C1 is greater than C2. Once again, concentration C1 is greater than C2 means here in C1 there is a excess of solid and C2 there is a excess of solid. And here we taken a membrane. This membrane is called as semi-permeable membrane. What? Semi-permeable membrane. Semi-permeable membrane means half permeable which allow only solvent molecule, to pass, because solid particles are larger in size. And solvent are smaller. So what happened here? In case of osmosis, this membrane which we used having a very fine holes, small holes, so it allowed only solvent molecule to pass, but it does not allow solid molecule. So what is meant by osmosis? The flow of solvent molecule. Let's say C1 is greater than C2, means concentration of solvent is less here and concentration of solvent is more here in solvent. So as per the definition of diffusion, so what will flow from where to where? The flow of solvent from here, higher concentration to the lower concentration. Okay, it allow only this membrane, allow only solvent molecule to pass. It does not allow a solid molecule. So here the flow of solvent molecule from solution of higher concentration to the solution of lower concentration through semi-permeable membrane. So flow of solvent molecule from a solution of from a solution of lower concentration to the higher concentration. Okay, so this is about the osmosis. Hope you understood. So you understood the difference in case of diffusion. In case of diffusion, solvent or solid molecule will pass both sides. Solid will go from here or here. Solvent molecule also pass from here to here. Okay, but in case of the osmosis, with the help of semi-permeable membrane, it allow only one component, or that is allow only solvent molecule to pass. So we completed with the definition osmosis. Now what is meant by osmotic pressure? So here, suppose I have taken a two compartment. One is a solution and second is a solvent or pure solvent. Okay, and this is separated. I have taken a simple, that is a membrane, that is your semi-permeable membrane. So osmosis will take place here. Yes, what will flow? The flow of solvent molecule, into the solution. Okay, the solvent molecule will flow from solvent to the solution side, because solvent concentration of solvent is more here and the concentration of solvent is less here. Okay, now suppose here I have put it, यहाँ से हम आउटलेट लगाते हैं, and here I have taken a piston here. Yes, I have taken here piston on solution side. With the help of this piston, I am applying a pressure. Due to this pressure, what happened here? The flow of solvent molecule will stop here. The osmosis pressure will be stopped. Because of this pressure, when I apply the pressure on the solution side, the molecule which is coming from solvent side will stop. So this extra pressure which is applied through the solution side is called as osmotic pressure. So we define what is meant by osmotic pressure. The net movement of solvent molecule, the net movement of solvent molecule from solvent to solution can be stopped by applying some extra pressure over solution side. Yes, the net movement of solvent molecule from solvent to solution can be stopped by applying some external pressure or extra pressure over solution side is called as osmotic pressure. Suppose if I apply more pressure, what happens? Just I apply the pressure, the net movement of the solvent molecule gets stopped. But if I apply more pressure, what happens here? The solvent molecule which is present in the solution will go into the solvent. So this is called as reverse osmosis. What? This is called as a reverse osmosis. So here this extra pressure which is applied on the solution side is called as osmotic pressure, which is denoted by the pi. Okay, so osmotic pressure is denoted by the pi. Okay.